All right, so let's go ahead and start with regular deposit savings. Now, I want to make sure that you know this is probably going to be a 30 to 45-minute video, but remember in class, I stop and have you guys actually do the math. And so that is what I'm expecting of you. I want, when I ask you to pause the video, I would like you to pause it and actually do the math. Me giving you the math and the actual number answer is not going to help you any. You need to know how to input it into your calculator. So please, please, please make sure you do take some time, pause the video, do the actual calculation in your calculator, make sure it is what you end up getting. All right. With that said, let's start the regular deposit. We did mention this in class, but I'm just going to do it as an overview. Regular deposit is at the end of each month, we deposit money into the savings account that pays a monthly interest of R for some amount of time T. The key question was, what type of interest is this? And the answer is, of course, it's compounding interest. I don't believe anymore in our world today we do simple interest. It just doesn't make sense. So everything in this will always be compound interest. It's always good to know what simple interest is and why compounding is better. But just so you know, everything will now be compound interest. So what happens is in real life, you have some kind of savings. I'm just going to change this to blue. You have some kind of savings when you start. And so this part of the equation is just to say, okay, say you already have $2,000 in your savings account. This is your balance when with time starting at 0. So when you decide to say, okay, I want to save up for a car, or save up for a vacation, or save up for a TV, a really big screen TV, you use this equation. And the first part, the V sub 0, is how much do you have in your savings account. This part is, of course, the interest that you accrue on this balance in your savings account. This is your monthly deposit. Oops, monthly deposit. And this funky equation, which remember, I also mentioned, I'm not going to go through deriving it, but it's the interest on your monthly deposit. Now, the reason it looks a little more complicated than this nice one that we know is because this takes into account, and again, I'm not deriving it, but it takes into account basically when the first month comes, you deposit, say, $100. That $100 is getting interest accumulated every month for T years. Next month, so let's say you were to do it for 5 years, so that's 60 months, 5 times 12, 60. So month 1, you put in a deposit. Well, it has 59 months that it's going to accrue interest. Month 2, you put in a deposit of $100. It has 58 months that it's going to accrue deposit. Month 3, you put in a deposit of $100. That $100 is going to accrue interest for 57 months. And so when you take all of that into account, we get this nice equation that, again, I'm not going to derive, that kind of basically accumulates all those interests together for every single month. So we do the addition because we are talking about regular deposits. So we are going to add to our balance. And again, B of T is balance after T periods. B sub O is the initial savings account balance. R is your interest rate, and A is the amount deposited at the end of every month. For us, for Math 100, we will just assume that our balance in the starting will be 0. So you can see if it's 0 and then you times it by anything, you'll just get 0. So we will not be using this part of the equation in Math 100. However, when you bring this onto your real life, whatever your balance is in your savings account, that is what you want to put in here. That is what you want to add to this equation. So, oh, and this just says that. So, just note that B sub 0 is if you had money already saved in your account. All right, so example 4 is asking you are saving to buy a car after graduation and deposit $100 at the end of each month at an APR of 4% compounded monthly. How much will you have towards purchasing a car in a year, in 3 years, and in 5 years? So, again, I will give you this equation on the exam, so you don't need to worry about it. But you do want to think about, okay, how much will I have deposited after a year? And again, we're going to assume that our B sub 0, our initial deposit, our initial amount in our savings is 0. This is just a brand new savings account. So so this part of the equation, we don't need to worry about. We're just going to concentrate on B sub t, or B of t is equal to our the amount that we are depositing every month times 1 plus r to the t minus 1 divided by r. Now I'm kind of making these two separate things. Remember, this a is a number, and it's just under 1. So technically, yes, you can bring this line out here. All right, so we want to know what B sub t is, and our t is 1 year. This is what we want to know. We know that t is equal to 1, is equal to n times your number of years. N is 12 because it's getting compounded monthly. There's 12 months in a year. 1 year is how much we're looking at. So our time we're looking at is 12. Our R, remember, that is going to be our APR divided by N. And in this case, it will be 0.04 over 12. Now, when you put this into your calculator, I believe it's 0.003, and the 3 just continues on forever. This is, if it's not a whole number, I just like to leave it in fraction form. And I strongly suggest you do the same and just have the calculator figure out the rounding. So I'm going to, and then one more thing, our A is $100. We're depositing $100 every month. So I'm literally putting all of this into this equation. And so I get B sub 1 is equal to $100 times 1 plus 0.04 over 12, all that raised to the 12th, to time t, which is 12 minus 1, and all that divided by 0.04 divided by 12. Now, the way I am going to do this, or actually, you know what, I will give you a chance. Go ahead and stop the video and calculate this number out for me. The R plus, 1 plus R to the t power minus 1 divided by R. And let's calculate it out to like 6 or 7 decimal places. So go ahead and stop and calculate it out. All right, so once you've calculated it, you should have gotten 100 times, oops, I'm sorry, I'm in the wrong section. Okay, 100 times, it should have been 12.2246288. I would strongly, if you didn't get 12.2246288, go ahead and try it again. All calculators are different. Some of them, you can literally just plug that in and it will figure out the order of operations. Other of them, you have to actually do the order of operations first. So you have to do 0.04 divided by 12, then add 1, then bring all that to the 12th power, then subtract 1, then divide by, and you either go 0.003333, keep going to like 7 or 8 decimal places, or you can do this first and then divide by that number. So when you do that, you should get 100 times 12.2246288. And that, of course, is just moving. Whenever you multiply by 100, you're moving the decimal place because you're multiplying, it's going to get bigger. So to the left, remember, left side of the number lines are always bigger numbers, 2 times. So we should get, that should be $1,222 and 46 cents. We always want to multiply, we always want to go up to the 2 decimal place, the second decimal place. And again, for rounding, if you want to round to the second decimal place, you have to look at the third one. And remember, if it's 5 or more, you round up 1. And if it's 4 or less, you keep the same. You just keep it. Keep the number as is. So for us, it's $1,222.46. So let's do what would be the amount we save if we had 3 years. Again, we want to know what B sub 3 is, or what B of 3 is. That's what we're trying to figure out. Our monthly payment is going to be, excuse me, I said payment, deposit is going to be $100 every month. Our R is going to be 0.04 divided by 12. Actually, I should rewrite that because I want to make sure I give you guys the right tools. Whenever you write R, you always want to write what it equals. So APR divided by N, and that is 0.04 over 12. And finally, our T is going to be N times Y, which is going to be 12 months times 3. So this one's going to be 36. So we have our equation. B sub 3 is equal to, and again, we're not worried about the beginning balance. We're just going to assume that is equal to 0. And if that's equal to 0, this whole part of the equation is just 0. So we are looking at our monthly deposit times 1 plus R to the T power minus 1, all that divided by R. There's a reason why I don't put the line all the way through, and it's we'll see this in example 5. But so we have 100 times 1 plus 0.04 divided by 12, all that raised to the 36th power minus 1, and all that divided by 0.04 divided by 12. And so again, take a second and go ahead and calculate this part, the interest part, and go out about 7 or 8 decimal places. Go ahead and pause and do that. And once you do that, you should have gotten 100 times 38.181562355. So that should be what this equals. And then, we're multiplying it by 100. So I'm moving this decimal place over 2. So I'm looking at, I'm looking at $3,818.01. And again, if we want to do the rounding for the second decimal place, we have to look at the third. That 6 tells me I need to increase the 5 by 1. And so I get 16. So $3,881.16. All right. So for the last part, part C, what I want you to do is pause right here and go ahead and tell me what B sub 5 is. What do you get as the answer for B sub 5? So go ahead and pause the video. All right, now that you're back, you should have gotten $6,629.90. And the way, again, you get that is we're trying to figure out what B of 5 is, or B sub 5 is. A, we know, is going to be $100. R is going to be our APR. And again, I really hope you actually wrote this down, APR divided by N, because one, the more you write down, the more you're going to remember. And two, if you mess up and you go straight to this equation and you mess this part up, at least I can see where you messed it up. For example, instead of 4.04 divided by 12, you just put 0.04. I will just assume you don't know how to calculate R, or you think R is 4%. Versus if you actually do it here and say maybe instead of 0.04, you put in, for whatever reason, 0.05, maybe you saw this 5 and thought it was 5%, at least I will know, oh, okay, they just used the wrong information. They know how to calculate R. So please, please, please always show all your work. And remember, you are in college, so you want to be able to tell people what you're thinking. And so T is going to be N times Y, which is 12 for N and 5 years for Y. And so you get 60. And so the equation we're trying to figure out is A times 1 plus R to the T minus 1, all that to the R. Excuse me, divided by R. And so when I plug everything in, I should get 100 times 1 plus 0.04 over 12, all that raised to the 60th power minus 1 divided by 0.04 divided by 12. And again, when you put this part into your calculator, you should get that should equal 66.2 989,782. And then you're rounding, so you're looking, you want to round the second decimal, so you have to look at the third, and that 8 tells you to go up 1. And so because it's oh yeah, I'm sorry, I got lost in the sauce. All right, because it's up, I know where I messed up. I forgot to multiply by 100. So, oops, go back to this guy. We're going to multiply by 100. And so when we multiply by 100, you move the decimal place over. So now it's over here. And this is where I got messed up, because I'm like, it's not 29 cents, it's 90 cents. Why is it not working? And so you want to look at, oops, I did it again, using the wrong place. So you want to, you want to look at the second decimal place, and you want to round that. So we need to look at the third decimal place, and that 7 tells us that we need to move the 9 up 1. So what you're essentially doing in your head, and this is a good example, is you're taking 0.89 and you're adding 1 to it. So 0.01, and that's how you get the 90 cents. So whenever it's a 9 and you need to move it up, you need to carry it over to the decimal place on the left. So that's how you get 90 cents. All right. So there are your answers for A, B, and C. And what I want to do now is answer this nice, good key question, which is, what about the interest we earned? Now, I know this is not part of your notes, but it's always good to know how to calculate the interest earned. And remember, interest earned is always going to be whatever your balance is minus your principal. To figure out what our principal is, remember that is just going to be how much we deposited every month times the number of times we do it. So times t. And so that's just a times n times y. So for this one, for the first year, our principal is going to be $100 times 12 months times 1 year. So we'll get $1,200. For for 3, it's going to be 100 times 12 times 3. And for 5, it's going to be 100 times 12 times 5. So when you calculate that out, you should get over here 30 for 3 years, 3,600. And for 5 years, you should get 6,000. And so now we're just going to use our balance minus principal to find out how much we actually earned in interest. And when you do that over here, the first year you get $22.25. The third year we get $218.16 that we earned in interest. And in 5 years, we get $629.90. So what I hope you can see is that as you go through, like the longer you put your money into a compounding interest account, the more money you're going to accrue. And it's not like it's going to double or triple. I mean, it did more than that. 22 times, plus 22 plus 22, it's doing more than that. It's going exponentially. So this is why it's always good to save in a high interest account, and so that you can earn more money. Let your money do the work. But the key thing I want you to get out of here is interest is going to equal balance minus the principal. Sorry. All right, example 5 is you want to buy a car 5 years from now, and you want $10,000 for the down payment. You noticed a new savings account at your bank that pays 7.2% APR. How much do you need to deposit each month to get $10,000 in 5 years? So this one is asking how much will we need to deposit. So here we're actually solving for A. We don't know how much A is, but we know our balance after 5 years, we want $10,000. So we're going to use that information and solve for A. Again, we're going to assume our initial balance is 0. This isn't always going to be the case. In fact, majority of the times it's not. So when you do this problem in the real world, take into account how much ever you have in savings. All right, so we know that B sub 5 is $1,000. We're trying to figure out what A is. We know R is equal to APR. And again, if I'm writing it down, you need to write it down, which is 0.072 divided by 12. And there's a reason why I picked 7.2%. It's because 72 divided by 12 is 6. So this will be 0.006%, just so it's something nice and easy we can work with. If you find something that pays you 7% interest annually, you should definitely invest in it. And just think like the longer you invest, it's going to compound faster and quicker. So T is going to be N times Y. And N is again 12, and Y is, we're talking about 5 years. So we're looking at 60 months, 60 periods. And so now I'm just going to plug everything that I have in my equation. So B of 5 is equal to A times 1 plus R to the T power minus 1, all that raised to, or excuse me, I keep saying raised, all that divided by R. And so when I do this, I get $10,000 is equal to A times 1 plus 0.006, raise that to the 60th power minus 1, and all that divided by 0.006. Now, there is nothing wrong with you undoing this and solving this like X. However, what I would strongly suggest, and this is, and one thing I kind of want to emphasize is A is being multiplied by everything here. It's not just being multiplied by the 1 plus r to the t. It's being multiplied by everything on the top. So what I strongly suggest is instead of undoing it, and I'll show you how it's done when you undo it, is go ahead and calculate this part out, because that's just a number. So go ahead and pause the video and calculate that part out. Right. So you should have gotten 10,000 is equal to A times, I believe it is 71.96473,533. So this hopefully will just look like as if I'm doing something like 3 is equal to 1.7 x, right? And so to solve for x, I'm just going to divide by 1.7 on both sides. So that's exactly what I'm going to do, is I'm just going to solve for a, I'm just going to divide by my number. It's a funky looking number, but it works. Math, once you know the foundation, it doesn't matter how funky or how complex a number is. The foundations don't change, right? So I'm going to divide by 71.96473,533, and I'll give you a second to do that. And tell me what you end up getting. Right. So you should have gotten $138.96. So this is kind of how I would do it, because seeing a complex number like this doesn't bug me. If you are like, no, but Visha, I want to solve for my A, which again is totally fine. Let's go ahead and do it the other way. And again, there's nothing wrong with it. So I'm just going to move this over here and kind of draw me some line. So I have a $10,000 is equal to A times 1 plus 0.006 to the 60th minus 1. And again, this whole thing is being multiplied by A. All that to the R power. Oh, oops, R is 0.006. I'm so used to writing out the equation first that I already forgot I did that. So R is again 0.0006. And so the first thing you want to do is get rid of your fraction. Remember, even though it's A by itself, you're going to put it under 1, then you just multiply the top and multiply the bottom. And when you multiply the top, A is being multiplied by both of these. So I am going to multiply both sides by 0.006. And when I do that, ooh, my zeros are looking like 6. When I do that, my fraction on the left goes away. This just becomes all 1. And on the right goes away. And on the left side, I get 60 is equal to A times. Now, I'm going to make this a little bit easier on the eyes. So 1 plus 0.006 is just 1.006. All that is raised to the 60th power minus 1. And so again, when you do this part, you should get 60 is equal to A times, and I haven't done it, so I did it the other way in my notes, to the 60th. You should have gotten something like 1.43, 1788412 minus 1. And so I get 60 is equal to A times, remember I'm subtracting 1, so times 0.4317884112, which again looks like a funky number, but you're just going to divide it. And this is why I was like, you know what, instead of doing all of this, which I'm going to end up dividing by something that looks funky, might as well figure out what this equation is. You can't really tell where I'm pointing, so let me change to the laser pointer, find out where this equation is, and then just divide it by that number. That's basically where I'm going with my thought plan. So go ahead and take a second and go ahead and do 60 divided by 0.0317884112. And you should get, I'm going to move it over here because I'm running out of space. You should get A is equal to $138.96. Again, either way you do it, as long as you're doing the math correctly, you will arrive at the correct answer. I just want to make sure that you realize this is a parentheses. The A is being multiplied to both the 1 plus R to the T and the minus 1. So just remember that, because if you don't, you'll get some very low number like $40, and that's not enough. That's not enough for you to get $1,000 or $10,000 in 5 years. So, okay. So a key question then is, what is the interest earned then? Remember, we have our, go ahead and do purple. We have our interest is going to be our balance minus principal. Well, our balance is, in 5 years, we want $10,000. Our principal, remember, principal is going to be the amount we deposit times the number of periods we deposit. And so that's just going to be A times N times Y. So we calculated that A is $138.96. I'm going to multiply that by 12 months, and we're doing that for 5 years. And so when I do that, I get, oh, actually I did do it. I get $8,337.60. You want to make sure you put the 0 on at the end, because we're talking about money, and money is 60 cents. It's 0.60 versus, I know mathematically 0.6 and 0.60 is the same, but this 0.60 shows the reader, oh, this is money. And also in science terms, when you add the 0 in the tens place, it's telling the reader that you measured up to that much and got that. That's how precise your measurement is. So it's very important to, especially when we're talking about dollars, to include, if it's 0 at the end, include that 0. So I'm now going to put $10,000 minus 8,337.60. I'm going to subtract it. And when I do, I get my interest that I got for that 5 years was $1,662.40. And again, don't forget your units. And this tells you that you basically, if you put in 100 and let's just say $40 every month for 5 years, you will get an extra $11600 at the end of that year for at a rate in an account of a rate that pays 7.2%. I think I mentioned in class the stock market is about 5 to 8% on average every year. Obviously, with stuff like, when you have crazy things like the pandemic happening, or there's a change in political power, or the housing crisis, things that will affect the stock market. Some years the stock market will go up double digits, other years it will go down. So on average, it will be about 5 to 8%. All right. I'm going to go ahead and actually start a little bit on installment loans. And then we'll probably start the example stuff in class on Thursday. So installment loan is an arrangement where the borrower, and this is the second case, where you borrow money, the principal. So the principal now is the amount that you borrowed, all right, from the lender for a fixed period of time called term of the loan, and you make regular payments. Usually this is done monthly. If you're a big corporation, it might be done quarterly, or they might do it semi-annually, but usually for most entities, it's done monthly. to pay off both the loan and the accrued interest. So here we are getting a principal amount to borrow. So like say you borrow $10,000 and you promise to pay that back in 5 years at, I don't know, 2% interest. Then what we're doing is now our B of 0 is going to be the principal amount that we borrowed. And then we are getting accrued interest on it. But every month you're paying off something. So that's why there's a minus sign. And this A now becomes your monthly payment. And again, this becomes the compounding interest that you're paying off on your monthly payment. So this is why loans go down, because of that minus sign, because you're paying off your balance, but it's not going as down as quickly as you want, because you have to pay off some of the interest. Like the person who loaned you the money has to make some money off of it. If you're lucky and you have parents or grandparents, or you got a nice trust, good for you. But majority of us are not going to be that lucky, and we will have to pay off. We will have some kind of loan in our life that we'll have to pay off. But that minus sign is what makes it worth it. So again, we borrow B sub 0. That's our principal that we borrow, and it's repaid in T years. In T time, equal payments of A. So we're paying installment payments of A, where the period interest rate is R. So to solve, to find out how much our regular payments are, we need to make the ending balance, the last thing, B sub T. So if it was 5 years, it would be B sub 5 or B of 5. We need to make that equal to 0 and solve for A. And this is the formula that everybody uses, banks, education, Department of Education. This is the formula that everybody uses for loans. And again, I didn't spend time in class talking about how we got this derived, but I want to spend this time to make sure you understand how to figure out how much your monthly payment will be if you're going to borrow something. This is very helpful, especially when you're going to go out and shop for cars or mortgage. You want to make sure nobody's going to be ripping you off. So and actually I think I will stop here, and we will do examples 6 and 7 in class, and we'll start nest egg in class as well, and then finish that up the following week. So thank you so much. Your homework for, let's see, do I have the homework slide? Let's see if I have homework slide. I don't. Okay, so your homework then, I'm going to stop sharing. Your homework for today is to finish part 1 and part 2 of the 10.3 homework that is already on Canvas. I will see you on Thursday. It is a Zoom meeting that we're going to meet, and I will record that one as well and post it. So I'll see you guys on Thursday. Thank you so much, and I hope you guys have a good day. Bye.